Excuse me, can you please help teach me how to find the domain and range of functions? Oh, you want to learn that? Then watch this video to find out. Several students over the period of time have found difficulties understanding the concept of domain and range and how to find domain and range of various functions. When you are done watching this video, you will know how to distinguish between the terms domain and range and how to find domain and range of several functions defined by an equation. So let's begin with the definition. By definition, the domain of a function is the set of all input values. So the values you put within the function are called the domain of the function collectively. And the range of the function is a set of all output values. After you put the input into the function, the result you get collectively is called the range of the function. Let's now look at two examples to augment your understanding of the definition of domain and range. We have two functions on the board and we are told to find the domain and range of each of them. So let's look at the first. We have in parentheses 2, 10. So this entire thing is a set, right? Enclosed by the pair of braces. Now 2, 10, 3, 10, 4, 20, 5, 30, and 6, 40. You already know that 2, 10, 3, 10 is a relation. 2 maps to 10, 3 maps to 10, and so on, as per our videos on functions and function notation. So let's find the domain of this. Again, the domain is a set of input values. So the domain will be all of the first values, right? First values are the input values. So 2, 3, 4, 5, and 6. This is the domain of this function. And the range is the output values or the second values. So the range will be 10. Now 10 is already there, so we're not going to repeat 10. We have 20, we have 30, and we have 40. Quick note, this is a function, but it is not a one-to-one function as per our definition of one-to-one function in our past video. So if you have not seen that video, I admonish you to check it out. Now let's move to the second part, part B. The domain is the set of first values. So the domain will be -5, 0, 5, 10, 15. This will be the domain as a set. And the range will be the output values or the second value in the other pair. So we have 4, we have 0, we have -4, -8, and -12. Now you have a tool in your tool belt to determine the domain and range whenever you are given a set of values that make up a function. Now that you know how to determine the domain and range given a set of values like this, it is a good time to give you a summary of the differences among inequalities, interval notation, and the graph of interval notations. In order to fully understand how to find domain and range of a function denoted by an equation, it is important that we teach you how to write a particular inequality interval notation and how to graph. So we have several different generalizations of how to write an inequality in interval notation and how to graph the result. So this is x is greater than a. Once you see this greater than sign, you use a parenthesis to show that this number a is not included. So since x is greater than a, it leads from a all the way to infinity, meaning all the numbers are greater than a upward. So infinity denotes a very large number in mathematics. So this is a comma infinity. So the graph of x is greater than a is going to be this. This is the parenthesis facing to the right. Great. X is less than a, meaning a is not included. So it's going to lead from negative infinity, from the negative number all the way to a. This is negative infinity comma a. And the graph is going to start from a and opens to the left. Good. X is greater than or equal to a. That means x includes A. The value, the range includes A as well. So we're going to use bracket to show inclusion and parentheses to show exclusion. So in this case, these two, for the two parentheses here, it means that A is not included. And for this, it means A is included. So we continue with x is less than or equal to A. There's a graph. It's the same thing, but you're going to use the bracket instead of parentheses. Now, what if the interval is between two set of values, A and B? So A is less than X and X is less than B. So X is between A and B. This is A comma B in parentheses, meaning A and B are not included. And this is a graph. A is less than or equal to X, which is less than B. This means A is included, but B is not included. So we use a bracket on A and parentheses on B. A is less than X and X is less than or equal to B, meaning A is not included, but B is included. And this is a graph. Also, A is less than or equal to X is less than or equal to B. A is included and B is included. And in the graph, you are going to represent A and B on the number line and use bracket on each of them to show that this interval we are discussing is between A and B. Great. Now that you have understood how to write a particular interval in inequality notation and to graph the result, it is important that we go on to find the domain or range of few functions. Let's now find the domain and range of a couple of functions. So A, find the domain of f of x equals to x squared minus 1. What is the domain of this function? Now, the domain of a function is a set of all values for which that function is defined. So in this case, we are considering a set of real numbers. So what are the values that s is going to assume for which this function is going to be defined? And the answer is all real numbers. So for every value, for every real number you put here, you're also going to get a corresponding real number for f of x. This is because x squared minus 1 is a polynomial. And in general, the domain of all polynomials is a set of real numbers. Therefore, the domain is the set of x such that x is an element of the real number. This is the domain of this function. Any real number you take and put in here, you are going to have a corresponding real number. Now, let's move on to B. f of x equals to x plus 1 all divided by 2 minus x. What is the domain of this function? Now, this is not a polynomial function. This is a rational function. It is the quotient of two functions f over g. So to find the domain of this function, we must understand that a rational function is only defined if the denominator is not equal to 0. That's when it is defined. So in this case, the domain will be all numbers, all real numbers, except those for which the denominator equals 0. So we say 2 minus x is not equal to 0. And then we solve for x. So 2 minus x is not equal to 0. We see x across, we have 2 is not equal to x. Because when x goes across, it becomes positive. So 2 is not equal to x, which means that x is not equal to 2. So the domain of this function will be the set of all x such that x is not equal to 2 and x is an element of the real number. So let's continue by finding the domain of the function f of x equals to the square root of 5 plus 2x. Now, in general, any function whose radical contains an even index is not defined when the radicand is less than 0. So to find the domain of any function whose radical contains an even index, it is always the case to take the radicand and say that that result, the radicand should be greater than or equal to 0. So in this case, 5 plus 2x should be greater than or equal to 0. And then we solve for x. By sending 5 across, we have 2x is greater than or equal to negative 5. And if we divide both sides by 2, we have x is greater than or equal to negative 5 over 2. To state the domain in set builder notation, we can write the domain is the set of all x such that x is greater than or equal to negative 5 over 2 and x is an element of the real number. So any value of x you take and place in here will be defined, except that those values should be greater than or equal to negative 5 over 2. Let's now find the domain of this last function and give you practice questions to do. F of x is equal to the square root of x minus 6 or divided by the square root of x minus 4. So the first thing we rewrite f of x as the long square root of x minus 6 or divided by x minus 4. We write f of x like this. And in order for this function to be defined, the radicand must be greater than or equal to 0, as per what we taught here. So we have x minus 6 over x minus 4 should be greater than or equal to 0. Now, to solve this inequality, we need to take each of these and let them equal 0. So x minus 6 equal to 0, in which case x equals 6, and x minus 4 equal to 0, in which case x is equal to 4. So we got two values here. We locate these two values on the number line. We have 4 and we have 6, right? But we know 4 is not included because 4 is in the denominator. So we open a circle on top of 4, meaning 4 is not part. Now we have three different intervals here, from negative infinity to 4, from 4 to 6, and from 6 to infinity. So first I want to choose any number between negative infinity and 4 and test it in this particular expression to see what the result will be greater than or equal to 0. So let's take a particular number. We take 3. 3 minus 6 is negative 3, and then 3 minus 4 is negative 1. Negative 3 divided negative 1 is 3, and 3 is greater than or equal to 0. So it means this particular interval, any number we take from negative infinity to 4 will work. Let's take number from 4 to 6. We get 5. 5 minus 6 is negative 1. 5 minus 4 is 1. Negative 1 divided 1 is negative 1. But negative 1 is not greater than or equal to 0. So this is negative and this is positive. Now the sign will always alternate, or the sign will always change whenever we leave from one interval to another. So positive, negative, positive. And we know that we are looking for intervals that contain positive values. Therefore, we are going to take the interval from negative infinity to 4, and we take the interval from 6 to infinity. So any number in here will make this function defined except otherwise. Therefore, the domain of this function is a set of values of x such that x is an element of negative infinity, 4 union 6, infinity. And we know that x should be an element of R. X should be a real number. So that's how we find the domain of a function. And our next video will be about finding range of a function. But before then, let's give you some practice questions to do on finding domain. Let's get it. So you are going to find the domain of each of the functions listed here and post your result in the comment section of this video. And we are going to look at your result and give you feedback as per whether your result is correct or not. Thank you very much for watching, and we see you in our next video. Bye.